So good morning all. Sorry for the slight inconvenience, like we were facing little bit technical issues, and today we will be discussing wave optics chapter. Let's start, okay, without wasting any time. So in this chapter you must have you have been introduced a new term, that is wave fronts. Okay, you know what is wave front? Like if there is a collection of points which is having same phase, that is wave front. Okay, it is kind of like our equipotential surface from electrostatics. Okay, so all these points are having same phase. So in like water waves, you can see like how it is coming. This is how we represent like spherical waves, okay, but in 3D. Understood? From a point source, the wavefronts will be spherical. From uniform, like from infinity a light source is there, then it will be parallel wavefronts like that. So and now you understood what is wavefront. Next is superposition of two sinusoidal waves. This we already discussed in SHM chapter. Like when we were discussing about SHM, what did we do? When two waves are superimposing, how it is behaving. That like introduction we already did. Here you can see there are two waves, x1, x2. When they are superimposing, we have to add them, and a result will be a sin omega t plus phi naught. What is the point here? Both are having same frequency and amplitude might be different. Phase difference will be there, but both are having same angular frequency. So that we should keep in mind. Then the resultant wave will have amplitude that is equal to a1 square plus a2 square plus 2a1 a2 cos phi. Phi is the phase difference between them. Just in case x1 is having x1 equal to a1 sin omega t plus phi 1 and x2 is equal to a2 sin omega t plus phi 2. Like that it is there, means we here phi will be equal to phi 1 minus phi 2. Okay, change in phase difference we have to assume there. And how to find this phi? That this phi naught, that is equal to a2 sin phi divided by a1 plus a2 cos phi. Okay, I hope that's clear for all. Here also phi you have to find like this. Is there any doubt regarding superposition and the final amplitude and phase? I guess not. Then depending on amplitude we can define intensity also. So intensity is proportional to amplitude square. How this relation is coming we will see in the next coming slides and we will discuss it. Okay. Before going into intensity and amplitude, we can see that there is a relation between phase difference and path difference. Okay, phase difference equal to k into path difference. Okay, phi is phase difference and delta p is path difference. Okay, both are related to each other. K we already defined before only, that is wave number. So k equal to 2 pi by lambda. So phase difference equal to 2 pi by lambda into path difference. Okay, this is the formula. Then you have to keep in mind. If you know path difference and lambda, you can find phase difference. If you know phase difference and lambda, you can find path difference. Okay, this is how. So this is what we are applying when we are studying like Young's double slit experiment, diffraction and all these things. We are applying basically this thing only to find constructive and destructive interference. As you can see, constructive means both are in same phase. Okay, so constructive interference, total amplitude will increase. Destructive interference means a trough and a crest are superimposing with each other, so destructive interference will happen. If both are having different amplitude, here we are assuming this and this are amplitude A. Here it will be sum of that, here it will be difference of that. If it is like A1 and A2, A1 plus A2 is happening, then our final destructive interference will be a wave only but with smaller amplitude. Okay, here the amplitude is increasing, here the amplitude will decrease. Okay, is there any doubt? I guess not, so we can move on. Next is intensity. Okay, intensity of the wave depends on amplitude. Basically, what is intensity? Intensity is energy per unit area per unit time. Okay, but it is depending on amplitude. If something is moving like more distance, more displacement is there, then it is having more energy, right, to move that much, which means intensity will be more. Based on that, we are getting this. See, these all are constant values, only amplitude can be varying. So we can say that, and also there is omega square. Okay, I proportional to omega square and a square. Omega is frequency, so omega square means we can also say that this is frequency square into amplitude square. They are independent of each other. For a same wave, we can keep the frequency same, increase the amplitude, intensity will increase, and we can keep the amplitude same, increase the frequency, still intensity will be increasing. So here mostly we will be using I proportional to a square. Okay, so if superimposition is happening, then new intensity, okay, intensity of new wave is equal to a1 square plus a2 square plus 2a1 a2 cos phi, right? Because a equal to root of a1 a2, a1 square a2 square plus 2a1 a2 cos phi. Now we are squaring the LHS side, so RHS side also square. This we can write as I1 plus I2 plus A1 we can write as root I1 and A2 we will write as root I2 and cos 5. Okay, is there any doubt? Now maximum intensity. Intensity will be maximum when phi is equal to what? Phi is equal to, like cos phi equal to 1. So cos phi equal to 1. When does this happen? When phi is equal to 2n pi. In that case, intensity will be maximum. There I max is equal to root of I1 plus root of I2. We can say that. Similarly, it will be minimum when cos phi equal to minus 1. That will happen when phi equal to 2n plus 1 phi. Okay. I minimum will happen when cos phi equal to minus 1 or phi equal to 2n plus 1 pi, which means 180 degree, like that. Okay, this is like 0, 360 like that. Here it will be 180, then next 180 plus 360, like that it will go. Now in this case, I minimum will be equal to root I1 plus I2 the whole square. I minimum will be equal to root I1 minus root I2 the whole square. Okay, so this is how we find maximum and minimum intensity, okay, with respect for superposition of two waves. Is there any doubt regarding any of this? Okay, so let's move on. And in this, one more thing I have to add, that is just in case, like let's say that our intensity of first wave and second wave is same, I1 equal to I2. In that case, intensity at any point we can find using I0 4 I naught cos square phi. Okay, if I1 equal to I2, at any point we can find intensity using this. Okay, next is Young's double slit experiment. In that mainly we don't want any explanation and all. You just need to know we are finding path difference. Okay, so at any point if you want to find, will it be like bright fringe or dark fringe, what we are doing? So this, let's say this is x1, this is equal to x2, and this distance is equal to y. First we are finding path difference. Path difference delta x will be equal to x2 minus x1. Once we get path difference, we can find phase difference. How? Phase difference is equal to 2 pi by lambda into path difference. So based on this, we can find, like we know when delta phi equal to 2n pi, it is constructive interference. When delta phi equal to 2n plus 1 pi, it is destructive interference. Substituting there, we are deriving like condition for constructive and destructive interference. So path difference, when we calculate, we are getting it as small dy by capital D. Okay, and for maxima, path difference should be n lambda. Okay, so n lambda, n starting from 0, n starting from 0, 0 at central maxima, there is no path difference. Okay, and from that we will get y, this distance equal to n lambda capital D by D. Capital D is distance from slit to screen, small d is like length between the like distance between the two slits. Now for minima, destructive interference, this is our condition. Both are fine only, both are correct. 2n minus 1 or 2n plus 1, both are correct. But thing is, if you are writing 2n minus 1, we are starting from 1, 2, 3. And if you are writing 2n plus 1, it is not this. We are starting from 0, 1, 2, 3. Okay, so if we are starting from 1, first 1, 2 minus 1, 1, 1 by 2 lambda d by d. If here this is plus 1, 0 means 1 by 2 lambda d by d, like that you can compare. Okay, so both are correct, only starting number will be different. If you are using this, fifth dark fringe will be n equal to 5 you have to take. If you are considering this fifth dark fringe, n equal to 4 you have to take. That is the only difference. So not getting confused, you can use first one for like avoiding confusions. Is it clear? Okay, moving on. Next is fringe width, on which we will be getting lot of questions from. That is fringe width beta, that is equal to lambda d by d. Interference pattern, all the bright fringe and dark fringe both will have same width, that is lambda d by d. This is the formula which I told. Like at any point, if you want to find what is intensity, it is equal to 4 I naught cos square phi by 2. Okay, now displacement of fringe. Now what we are doing is, like let's say the in the two slits, okay, we are placing a glass slab of T thickness and mu refractive index. In that case, there will be shift in the fringes. Shift will be towards the glass slab. Okay, so initially central maximum was here, it will shift upwards. If glass slab is placed down in the downward slit, it will shift downwards. How much shift will happen? This is that formula, mu minus 1 d by d, or mu minus 1, okay, here also t is there, t into b by lambda. Okay, this is the formula which you can use to find how much the shift is happening. Is there any doubt? Okay, let's see next one. Next is diffraction. Okay, in diffraction we don't need any other confusing things. We only know that central maximum will have maximum width, all other will have same width only. Okay, central maximum highest intensity, then intensity will decrease as we move away from the center. Okay, here the formula is n sin theta equal to path difference. Okay, path difference, A sin theta. A is the width of the slit. Okay, sin theta is angle, angular width to the, so if we are taking this point, what is this angle? This is theta. Okay, and here for maxima it is 2n plus 1 lambda by 2, and for minima it is n lambda d by a. Here also d is there. Okay, for maxima a sin theta into 2n plus 1 lambda by 2. So we can say that a, sorry, okay, y equal to, here d is not there, y equal to, when we substitute sin theta equal to y by d, then we will get y equal to 2n plus 1 lambda d by a. This is for maxima, and for minima you get this equation. Okay, is there any doubt? Only these two equations you have to learn. And for angular width is sin theta. Okay, sin theta we are finding, that is y by d. So if you have equation for y, just substitute it here, then you will get equation for theta. Like when theta is very small, sin theta approximately equal to theta. Okay, is there any doubt? Okay, I guess not. So we can move on. Next is polarization. Okay, polarization means when light is moving, we usually represent, this is the direction of propagation, light is like electric field is oscillating in this direction, magnetic field oscillating in this direction. That is for one ray. Okay, another ray might be there here whose electric field is oscillating in this direction, magnetic field in this direction. Okay, like that so many rays are coming together when a light is coming, right? So each ray might be oscillating in different direction. So that is unpolarized light, oscillation in all direction. When we pass it through a filter, that is called as polarizer. When we pass it through that, we will confine it for oscillation in only in one direction. So this is a filter which will only let light oscillating in this direction pass through it. So all the other will be blocked. Okay, so let's say I naught intensity, initially it was coming. After going through polarizer, there will be intensity I naught by 2 only. Okay, then another thing called analyzer is there. Analyzer means again after polarizing, we are keeping it at some angle with the polarizer and we are passing the light through it. So through polarizer, unpolarized light is coming. Through analyzer, polarized light is passing. So here I naught intensity was coming. Here it became I naught by 2, let's say I1. After analyzer, let's say this angle is theta. Okay, so after analyzer, this much will be the intensity, okay, or at the light of the light. This you need to know. After polarizer, intensity becomes half, and again if it is passing through an analyzer, its intensity will be this, let's say this is I1 cos square theta. Okay, this you should remember. Is there any doubt in this? Okay. Moving on, next is Brewster's law. This, based on this, I think we had a question in our mock test. As you can see, when at a particular angle, when the light is falling on a surface, every time there will be some reflection, some refraction, okay? But at this particular angle, all the reflected light will be fully polarized, okay? This will be fully polarized when it is falling at one particular angle. And dot means it is oscillating perpendicular to the plane. This arrow means oscillating parallel to the plane. So fully polarized perpendicular to the plane, and a refracted one will be partially polarized, okay? And at that point, when that is happening, angle between reflected and refracted rays 90 degree, okay? So this can be told as, this is what, that is equal to 90 minus theta. So let's say theta b is Brewster's angle. This theta delta will be equal to 90 minus theta b. On substituting that, we will get the formula N2 by N1. N2 is second medium, denser medium. N1 is rarer medium. N2 by N1 equal to tan theta b. Okay. Is there any doubt? This is from Snell's law only, because Snell's law said that N1 sin theta b equal to N2 sin 90 minus theta b. That is angle of refraction. So sin theta b divided by sin of 90 minus theta b equal to N2 by N1. Sin 90 minus theta, cos theta. Sin theta by cos theta, tan theta. This is how we are getting the formula. Okay. Anyone have any doubt in this? Or any of the previous topic we discussed? If no doubt, means we can move on. Starting from the first question. Okay. Intensity of transmitted light when a Polaroid sheet placed between two Polaroids at 22.5 degree from the polarization axis. One of the Polaroid is I0 is the intensity of polarized after passing through the first Polaroid. Okay, so one Polaroid is there. When light passed through it, intensity is I0 after passing. Okay, then a Polaroid sheet placed between two crossed Polaroids at 22.5 degree, okay, from the axis of polarization of one Polaroid. Okay, so compared to 2, it is having 22.5. So compared to 1, it is having how much? Like both are parallel to each other, okay? First one and third one are parallel to each other. Second one is at angle 22.5. Now what we are doing? We will be writing it as after first one. Here intensity, let's say I1. I1 is equal to I0 cos square. Instead of writing 22.5, we will write what? 45 by 2. 45 by 2 is 22.5. This is I1 at this point. Now after passing through second one, this will be I2. I2 is what we have to find. I2 is equal to I1 cos square, again 45 by 2. Okay, sorry, not cos square, 45. So with this it is having 22 degree. Next one, two crossed Polaroids, right? So next one is having 90 degree with the first one. So this will be 90 minus 45 by 2. Okay. two crossed polaroids they are saying. So first one is in one direction, second one is perpendicular to that, and it is having 22 degree with first one. So with second one it will have 90 minus 22.5. Now substituting I1 here, we will have I naught cos square 45 by 2 into 90 minus cos 90 minus theta is sin theta. Okay, so sin square 45 by 2. Okay, next what we are going to do is, we know sin theta cos theta. 2 sin theta cos theta is equal to what? Sin 2a, so 2 theta. Okay, so this we can write as sin square 2 theta divided by cos square theta sin square theta can be said to be sin 2 theta square divided by 4. Substituting that, we will get I naught by 4, then sin square 2 theta will be 45, sin 45 is 1 by root 2, square 1 by 2. So this will become I naught by 8. Answer option A. Did you understand it? Okay, second one is in perpendicular to first one. Okay, 2 perpendicular with 1. Is there any doubt? If not, let's move on. Next one. An unpolarized light beam traveling in air is incident on a medium of refractive index 1.73 at Brewster angle. Then, okay, 1.73, that we can write as 1.73 can be written as root 3, right? So this is refractive index mu. At Brewster angle means we can say that mu equal to tan theta b. Okay, so tan theta b equal to root 3. When is tan theta root 3? For 60 degree. So theta b is equal to 60 degree. Okay, so angle of reflection is close to 60 degree. Reflected light is completely polarized. This will be the answer. Okay, here transmitted light is completely polarized, that is not true. Then reflected and transmitted perfectly polarized, that is not true. Reflected light partially polarized, that is not true. Even though angle wise everything is true, because of the first point only C is correct. Okay, I hope then we can move on. Next one, 2 slit in Young's double slit experiment are at 1.5 millimeter, D equal to 1.5 millimeter apart. Screen is placed at a distance of D equal to 1 meter. Wavelength of the light used is lambda equal to 600 into 10 to the power minus 9 meter. Then fringe separation is same as fringe width. Okay, same problem we had in mock test. So fringe width beta is equal to lambda capital D by small d. Direct application, you can get the answer. That lambda equal to 600 into 10 to the power minus 9 d 1 meter divided by 1.5 I am writing as 3 by 2 into 10 to the power. What? Yes. Yes, we have to convert millimeter to meter. Then only we will get the answer. That's why I write 10 to the power minus 3. Okay. So you will have here 200. So 200 into 200, 400 into 9 minus 3, that is 10 to the power minus 6. Okay. So out of that, which option will be correct? This is our final answer. If you are writing only one digit, 4, so into 10 to the power minus 4. Okay, answer option D. Okay, I hope there is no doubt in this question. Like whenever you get, first check if the options are in meter, SI unit. If option is in SI unit, we have to convert everything into SI units. Only one difference is there if you are taking a ratio of same material, like length by length you are taking, then no need to convert. Centimeter, centimeter, it will get cancelled off. So except for taking ratios, all other calculation you have to convert to SI unit if answer is in SI unit. Okay, I hope we can move on. Next one, interference pattern can be observed due to superposition of following waves. Choose the correct out. Like there are these 4 waves, because of which 2 waves we can find interference. Option C, yes, correct. Why? Because I told you amplitude can be anything, but frequency should be same. That is only for A and C. So answer is option C. Very good. Okay, then we can move on to the next question. A linear aperture whose width is 0.02 centimeter is placed immediately in front of a lens of focal length 60 centimeter. The aperture is illuminated by a normally parallel beam of wavelength 5 into 10 to the power minus 5 centimeter. The distance of first dark band of diffraction pattern from the center of the screen is. So linear aperture whose width, this is what A equal to. Okay, A equal to 0.02 centimeter in front of a lens of focal length 60 meter. Focal length of lens equal to 60 meter. So you might get confused. Why we are talking about lens in this chapter? Okay, in the last chapter ray optics we already talked about lens. Why we are talking about it again? Let's see. And lambda is given as 5 into 10 to the power minus 5. You have to find first dark band of diffraction pattern from the center of the screen. So if we are finding diffraction like dark band, y should be equal to n lambda d by d. This is the formula we already know. N should be equal to 1 if we are finding first one. So y equal to lambda d by d will be, sorry, A will be, this is A, sorry, A will be our answer, but D is not given. Some other focal length is given. Okay, why this is? Because let's say the light is coming parallelly from a large from a long distance. If you keep a converging lens here, this will all be focused coming to and forming image at the focus, right? So if you keep a screen at the focus, you will get all the pattern in the screen if we are keeping screen at the focus of the lens. Okay, so this is same as our diffraction. So this focal length will be equal to D. I hope when you are studying wave optics for your CBSE, you studied about Fresnel and Fraunhofer diffraction. Okay, in this is Fraunhofer diffraction, where we are using lens to create parallel rays and also focusing on the screen. So from this we will get F equal to D, Y should be equal to lambda F by A. Okay, everything is given in the question. You can calculate the answer. It will be equal to 5 into 10 power minus 5. Option? Sorry, I did not hear.
D.
B or D? D. Yes, correct. Option D is the correct answer. And focus is 60 centimeters. So 60 into 10 power minus 2 divided by A is 0.02 into 10 power minus 2. Okay, so option D is the answer. Let's move on. Next one, interference pattern is obtained with two coherent light sources of intensity ratio n. In the interference pattern, ratio Imax minus Imin will be Imax minus Imin by Imax plus Imin will be. Okay. Now coherent source means both are having like same phase, same amplitude, same frequency, those things. Okay, that is the meaning of coherence. So intensity of 1 divided by intensity of 2, this we got as n. Okay, that is given in the question. Intensity ratio equal to n. So this can I write as n by 1. Okay, so if I1 equal to n, I2 equal to 1, like that. Now for Imax, how did we say? Imax is equal to root I1 plus root I2 the whole square. Similarly, I minimum equal to root I1 minus root I2 the whole square. I1 and I2 are these values. So if you substitute, you will get root n plus 1 the whole square, and here root n minus 1 the whole square. Expand these, then substitute in this. I max minus I minimum divided by I max plus I minimum. Okay, this you will get as n plus 1 plus 2 root n. This you will get n plus 1 minus 2 root n. Numerator is I max minus I minimum, so this will get added up. You will get 4 root n divided by adding these two, 2n plus 2. Okay, so 2, let's take common, you will get 2 root n divided by n plus 1. This will be the answer. Option B. I hope you are understanding this. Okay, I1 by I2 is given ratio, so we are just using it to find I max and I minimum, then substituting it to find the answer here. Okay, let's move on. Sorry, you saw the answer. If you in a diffraction pattern due to single slit of width A, first minimum is observed at an angle 30 degree when light of wavelength 5000 Armstrong is incident on the slit. First secondary maximum is observed at an angle of. Okay, so angle A sin theta is equal to what? And they are talking about minimum, so it is equal to n lambda for minimum. Okay, this we can use. A sin theta equal to n lambda. Now they are saying first minimum at angle 30 degree. So when n equal to 1, theta equal to 30 degree. So sin 30 is equal to lambda by A. Sin 30 equal to 1 by 2. Lambda by A equal to 1 by 2. Let it be here. Lambda is given. Secondary maximum observed at an angle. So you have to find secondary first secondary maximum. Okay, so secondary maximum we have to find. So for that equation is A sin theta equal to, this is for minima, for maxima it will be equal to 2n minus 1, 2n minus 1 lambda by 2. Okay, now we have to find this angle for n equal to 1. Okay, first secondary maxima we have to find. So for n equal to 1, what will happen? A sin theta equal to lambda by 2. Okay, then we will write sin theta equal to lambda by a into 2. This we will get as what? Lambda by a is 1 by 2. So this is equal to 1 by 4. Okay, so answer is okay, I guess we have to find for n equal to 2 secondary maximum, right? N equal to 2 we have to find. So 4 minus 1 3. 3 lambda by 2 3 3 by 4. Okay, so answer is sin inverse 3 by 4. If you are taking first maxima, then we have to take n equal to 1, but here they are saying secondary maxima, so we are taking n equal to 2. Okay, is there any doubt? First we found what is lambda by a from the given thing in the question, like sin 30 degree first minima. Then for second maxima we are using for condition for maxima and substituting lambda by a there. That's it. If no doubt means we can move on. Next one, the intensity at the maximum in a Young's double slit experiment is I naught. Distance between two slits is 5 lambda, where lambda is the wavelength of light used in the experiment. What will be intensity in front of one of the slits in screen placed at distance d equal to 10d? Okay, so let's say this is our slit and this distance is d. Okay, this is given as 5 lambda. Now maximum intensity is I naught at this point right in front of one slit. What is the intensity? That is what we have to find. Okay, this distance is d, which is equal to 10 small d. So d can also be said as 10 into d, that is 50 lambda. This is also there. Now from this point to this point, what will be this distance? We have to find path difference, right? What will be this distance? Using our Pythagoras theorem, this is our hypotenuse. So this distance will be equal to d square plus small d square. Okay, so which we can say 100 d square plus d square the whole root. Okay, this will be equal to d into root of 100 plus 1. Okay, is that the value? Anyway, we from at this point we have to find the path difference. Okay, so d, let's say if this distance is equal to x, d minus x we have to find. That will be equal to our path difference delta x. If you know path difference, you can find if you can find a path difference, then you can find this thing, phase difference. Delta phi equal to 2 pi by lambda into delta x. After finding phase difference, you can find intensity. Maximum in a Young's double slit experiment is I naught when phi equal to 5 by 2 equal to cos equal to 1. So I equal to I naught cos square pi by 2. This you can find. Okay, is there any doubt? Okay, answer is option B, I naught by 2. Method is this: we will find path difference. Path difference into 2 pi by lambda equal to phase difference. Everything is given in terms of lambda. So you can find lambda will cancel. You can find a value for pi 5. Then you can substitute it here to find what is like intensity at any point. Okay. Next is, two slits in Young's double slit experiment have width in the ratio 1:25. So in the slit experiment, okay, double slit experiment, one is having width 1 and another is having width 25. Ratio of intensity of maxima and minima in the interference pattern is I max by I min. So let's say total intensity of the light is I naught. Okay, then here if you are taking intensity as I naught, here it will be 25 I naught intensity. So this is equal to I1 and this is equal to I2. If this is the case, I max will be equal to what? I max equal to root I1 plus root I2 the whole square. Root I1 will be root I naught. Okay, root I naught plus this will be 5 root I naught the whole square. Root I naught we can take outside, it will become I naught. 1 plus 5 equal to 6. 6 square is equal to 36. Okay. Similarly, I minimum you want to find. Okay, this is I2, this is I1. Because for finding I minimum will be root I naught, root 5 I naught minus root I naught the whole square. This you will get as I naught into 5 minus 1, 4. 4 square 16. Okay. Now I max my I minimum will be 36 by 16. That will be equal to 9 by 4. Answer option C. Okay. Is there any doubt? I guess not. Let's move on then. Two slits in Young's double slit. Okay, same thing we did. Next one, unpolarized light is incident from air on a plane surface of material of refractive index mu. At a particular angle of incidence I, it is found that reflected and refracted rays are perpendicular to each other. So, if reflected and refracted ray are perpendicular to each other, incident angle is Brewster's angle. Which of the following options is correct? Reflected light is polarized with electric vector parallel to the plane of incidence, which means reflected light should have arrows instead of dot. But in the figure we saw it is dot only. So this is wrong. Next one, reflected light is polarized with its electric vector perpendicular to the plane of incidence. That is correct. Okay. Here it is not tan. A correct option will be I equal to tan inverse mu. Okay. This is the correct answer. So B is the correct option. Is there any doubt? Okay, let's move on then. Next one, Young's double slit experiment is first performed in air, then in a medium other than air. It is found that 8th bright fringe in the medium lies where 5th dark fringe in air lies. Refractive index of the medium nearly is. Okay, 5th dark fringe, if you are taking, we have to find y of 5th dark is equal to what? 2 into 5 minus 1 lambda d by 2d. This is the formula for dark fringe. Here I am writing lambda naught for air. Lambda naught wavelength in air. Okay. Now they are saying this is equal to what? 8th bright fringe in the medium. Okay. So why 8th bright in the medium is equal to n lambda d by d, right? So 8 lambda in the medium d by d. So when we are shifting the experiment from one medium to another medium, we are not changing slit width or screen distance. Nothing we are changing. Only lambda will be changed. Okay. Lambda m wavelength in medium. Okay. So for finding refractive index mu is equal to c by v, right? Velocity in vacuum or air divided by velocity in medium. This we can write as lambda naught by lambda m. This is refractive index. So for finding refractive index, this we already equaled. Lambda naught by lambda m we have to find. So lambda naught by lambda m. Here only dd will get cancelled. You will have 8 into 2 divided by 2 into 5, 10 minus 1, 9. Okay. So this is equal to 16 by 9, and when you solve it you will get the answer. Okay. Answer is option C, 1.78. Okay. I hope you understood the method. Refractive index is c by v, which means change in wavelength. By wavelength also we can find. Since from the things given in the question, we are finding lambda naught by lambda m. Okay, next is two Polaroids P1 and P2 are placed with their axis perpendicular to each other. Unpolarized light I is incident on one, and third Polaroid P3 is kept in between P1 and P2, that it makes an angle of 45 degree of P1. Intensity of transmitted light from P2 is, okay. So this is P1, then there is another polarizer P3, this is P1, and this is at 45 degree, and another polarizer is there which is perpendicular to it. Okay, at like perpendicular to P1. This is P2. Now what is given? Makes that an angle 45 degree. Intensity of transmitted light. So initially unpolarized light of I0 is coming. So after P1 it will become I1, after P3 it will become I2, here it will become I3. We have to find I3. Okay. I1 is equal to I0 by 2. There is no change there. After first polarizer, intensity becomes half. We already said. I2 is equal to I1 cos square 45. Okay. I1 cos square theta. That is the formula for analyzer. Then I3 is equal to I2 cos square 90 minus 45 also 45. So here also it will be 45. Now what we will have, like I2 is equal to I1 is I0 by 2 cos square 45. Then I3 will be equal to I0 by 2 cos square 45 into cos square 45, right? Cos 45 is 1 by root 2 square 1 by 2, 1 by 2 into 1 by 2, it will be 1 by 4, 1 by 4 into this, I0 by 2 into 1 by 4, that is equal to I0 by 8. Answer is option B. Okay, is it clear? Is there any doubt in this? If not, let's move on. Next is, in Young's double slit experiment, if the separation between coherent sources is halved, which means D is becoming D by 2 and distance from the screen from the coherent source is doubled. So D is doubling. Then fringe width becomes, fringe width equation beta equal to lambda D by D. So new fringe width beta dash will be equal to lambda D dash by D dash, that is equal to 4 lambda D by D. Okay, when you substitute this is equal to 4 beta, so it is increasing 4 times. Screen is not visible. Why? Is it like network issue? Is it visible now? Guys, okay. So it is increasing 4 times. Okay. Next one. For Young's double slit experiment, 2 statements are given below. Statement 1. If screen is moved away from the plane of the slit, angular separation of the fringes remains constant, which means if like this is slit, this is screen, if I move away, angular width of the fringes will remain constant. Okay, see our equation is lambda by D is equal to D sin theta. Okay, this is from D sin theta equal to n lambda. Okay, this is the equation for maxima in Young's double slit experiment. Okay, this sin theta we are approximating to be y by d and we are substituting. See, if you are increasing that, this theta is not going to change. Okay, theta value will remain constant only. So first one is true. Next one, if the monochromatic source is replaced by another monochromatic source of larger wavelength, angular separation decreases. When lambda is increased, theta is also increasing, right? So second one is false. So answer is option B. Statement 1 is true, but 2 is false. This same formula we are using in diffraction also, but instead of D it will become A sin theta equal to n lambda. It is for maxima, that will be for minima. That is the only difference. Okay, moving on. Next, in a Young's double slit experiment, a student observes 8 fringe in a certain segment of screen when monochromatic light of 600 nanometer wavelength is used. If the wavelength is changed to 400 nanometer, then number of fringe width he would observe in the same region. Okay, so in some region, let's say this much region, 8 fringes are observed, which means beta is the width of one fringe. Beta into 8 will be that length, right? So 8 fringe means length x equal to, okay, I will draw properly so that you won't get confused. In this much region, 8 fringes. Okay, this distance is equal to x. So x is equal to 8 beta. Okay, this is equal to 8 lambda capital D by small d. Now they are saying it is changed. D and D is kept same, but lambda is made into 400. Okay, so that will become like x is not going to change, distance is remaining same, but number of fringe will be different. So n lambda 400 d by d we have to equate. D cancel, n we have to find, so 8 into 600 divided by 400 equal to n. Okay, equal to 12. Answer is option D. Is it clear? Okay, then we can move on to the next question. Next one, a beam of unpolarized light of intensity I0 is passed through Polaroid A, then through another Polaroid B oriented at 60 degree, and finally through Polaroid C 45 degree relative to B. Intensity of the emergent light is. Okay, so I1 here, I2 here, I3 here. I1 equal to I0 by 2. I2 equal to I1 cos square 60. I3 equal to I2 cos square 45. Okay, then I2 we can write as I0 by 2, cos 60 is equal to 1 by 2, the whole square is equal to 1 by 4, which is equal to I0 by 8. Here it will be I2, that is I0 by 8 into cos square 45. Cos 45 1 by root 2, square 1 by 2, this is equal to I0 by 16. Answer option A. Okay, we did so many questions from this polarizer and analyzer. I hope you will be able to solve such question in exam also. I think we can move to the next question then. Next one, if the monochromatic source in Young's double slit experiment is replaced by white light, then, okay, when white light is placed for Young's double slit experiment, central maxima will be white, because there will be zero path difference for all the wavelengths. If you take violet, indigo, blue, green, everything, center will be zero path difference for everything. As you move away from center, for different lambda, different path difference will happen. So center maxima will be white, and as you move away, colors will start appearing. So in that, in the all options, the correct one is option C. Center bright white fringe surrounded by colored fringes. Okay, this is the answer. Last question for today. An unpolarized light beam strikes a glass surface at Brewster's angle. Then reflected light will be partially polarized. No, it will be fully polarized. Refracted light will be completely polarized. No, because it is partially polarized. Both the reflected and refracted light will be completely polarized. No, reflected light will be completely polarized. Refracted light will be partially polarized. This is the answer. Okay. So I hope today's class was useful for you all in understanding the chapter wave optics. Tomorrow we will be discussing modern physics, which will be including our atoms and dual nature of light, these two chapters. So you can join back for chemistry class at 12 o'clock. Now